this is something totally new. These are called parametric equations. What the heck is that? Let me give you an example. We'll start with two-dimensional. Tonight's homework is all two-dimensional parametric equations, but when we get to the second worksheet and the third one, then it's going to be three-dimensional parametric equations. So let me give you an example. We'll start off easy. X equals 2t plus 1. Y equals t minus 1. What the heck is this? Well, you have a particle that's moving in the Cartesian plane as opposed to space according to these equations. So this equation tells you what the x coordinate is. This equation tells you what the y coordinate is. And t is like a third variable. We call that the parameter. That's why we call these parametric equations. So if you're going to study physics or engineering, this is critical. So basically, you're giving the position of the particle, and that's a word you guys know from physics, right? Position. Because once you, see, this is the thing. Once you know how to get the position equations, then we use calculus to figure out the velocity and acceleration. Right? That's what you guys do in physics. But if you have calculus, it makes it a lot easier. So, if you think of t as time, it might make it easier for you to understand, but it doesn't have to be time. T can just be a third variable. Because if t is time, then there's no such thing as negative time, right? But t can represent any variable. But so, like I said, to make it easier for you, think of t as time. Okay, so what if we're given a time interval? T is greater than or equal to 0. That's called t time. Well, how can you tell how the particle is traveling in the Cartesian plane? Well, when you first learn, you start by making a chart like this. So t, x, and y. So t is greater than 0. Think of t as time again, so 0. And I would guess if you just plot these 5 points, you can get an idea of what's happening. So what would happen if I plug in 0 for t into the first equation? 1. And what about for y? So that means at the very beginning, the particle is at the point 1, negative 1. This is when t is equal to 0. What do we call this in physics? Physics, people? This is called your initial position. Right? And then with calculus, we can figure out initial velocity and initial acceleration. Now, let's say t is measured in seconds. Where would the particle be 1 second later? Well, you simply plug in 1 for t here and here. What happens when you plug in 1? 3, plug in 1. Yeah. So 1 second later, the particle is at the point 3, 0. So here is the particle 1 second later. Where is the particle 1 second after that? Well, plug in 2, and you get 5, 1. So now the particle is at the point 5, 1. So this is when t is 2. What about when t is 3? Come on, you guys can plug in. 7, 2. I guess we got better extend this then. So 7, 2 would be up here. So here's the particle when t is 3, and let's just do one more. What about when t is 4? Plug in 4. 9, 3. So 7, 8, 9, 3. So here is the particle when t is equal to 4. So what does it look like? What kind of path is the particle tracing out? Well, if we connect the dots, hey, Mr. Park, it kind of looks like a line. And then, of course, if you keep on going, it looks like it's going to keep going up. Can we be certain it's a line, though? How do we know it's a line? All we know is the particle is here at 0, 1, 2, 3, and 4. How do you know what it's doing in between? How do you know it's not doing this? Sometimes they do that, you know. How do you know the particle is traveling in a straight line like that? Well, what we do is we eliminate So which equation does it look like it's easier to solve for t? The second equation. So if you solve for t, you get t is equal to y plus 1. Take that and plug it into the first equation. Or if you want to, you can solve for t in the first equation, plug it into the second. It doesn't matter. So you basically got to do algebra. So x equals 2t, but what is t equal to? Y plus 1 plus 1. Simplify this. X equals 2y plus 2 plus 1. So x equals 2y plus 3. And then we want to solve for y. So 2y is equal to x minus 3. Y equals 1/2 x minus 3/2. What is this an equation of? A line, right? Y equal mx plus b. Now we know for a fact that the particle doesn't do strange things in between. It just travels in a straight line. So, and you can also graph this, I'm going to show you how to graph this on your calculator. You have to go into parametric mode, because that's what we're doing here. See, but on your calculator, the thing graphs it so fast, you don't even know what it's doing. So you're just going to see this. But see, when you take calculus, just like polar graphs, it's not enough to draw the graph. You have to know how it's traveling on the graph. So before in this class, they used to have to write a paragraph that describes how the particle is traveling on this graph. So they used to say things like this. Well, the particle has an initial position of 1, -1, and then it travels up the line, y equal 1/2 x minus 3/2, with a constant speed. How do you know it's a constant speed?
It's a straight line.
Well, no, not just a straight line, because sometimes it does this, you know. And then it slows down. How do you know in this case it has a constant speed? Because it travels the same distance from here to here. What is this distance? Hello? Here, let's make a right triangle. If this is 2 and this is 1, wouldn't there be root 5 then? It travels root 5 every second. But then from here to here, it traveled the same distance in 1 second. So that's why it's a constant speed. It travels at root 5 units per second. It's a constant speed. Is it a constant velocity as well? Physics people? Velocity is a vector. Is the vector remain the same throughout? Yeah. So it's constant velocity, constant speed. Okay, but you don't have to know the physics part. All I want you to do is tell me how the particle travels on this line, and there's lots of ways of doing it without writing a paragraph. So you can just do something like this. Just draw this. That way you don't have to write a paragraph. But then again, you're not going to get too many easy ones like this. This is just to help you understand. Okay, now we're going to kick it up a notch. Okay, any questions on this before we get into the tougher stuff? Here we go. X equals cosine t. There's going to be a lot of trigonometry. Y equals sine t. And let's say t is greater than or equal to 0. So that means t is time. Okay, now, what you're going to do on the, you know what? I'm not even sure we're going to have a quiz on this. There might be just a test since there's just 3 sections. But I have a quiz on the assignment sheet. I might take that one off. We'll see. So what you're going to have to do is, these are going to be the directions, okay? Write the rectangular equation that the particle is traveling on. In other words, this one right here. That means you have to eliminate the parameter. And then you have to tell me how the particle is traveling on the graph. So the first thing you do is, you want to eliminate the t. Now, normally, when you have something like this, solve for t in one equation, plug it into the other one. But when you have trigonometry, you probably want to use identities. Do we have any identities that have cosine and sine in it? What's the most important identity in trigonometry? Cosine squared plus sine squared equals?
1.
Yeah, well, Mr. Park, that's not cosine squared and that's not sine squared. So what do you think I'm going to do with the equations? I'm going to square them. So square the first equation. Square the second equation. rational functions, you know, the kind with the vertical, horizontal, and slant asymptotes. It's all gonna be in this chapter. Okay, so what you do, this is what you're gonna have to do. Draw this graph, but draw it in a dotted line. Do not use a solid line. Okay, so the particle is traveling on this circle here. But now you have to tell me how the particle is traveling on the circle. So, we can make a chart like this. If you want me to put the chart on the thing, I will. Or you can just do it in your head. You know what? We're gonna make the chart this year. I'm gonna give you the chart, and I'm gonna even tell you what numbers to plug in, because sometimes students, they can't figure out, like, what number should I plug in? Well, greater than or equal to 0. So you know what some students do? They do this. Why would this be bad for this problem? Here are your original equations right here. Now I know everybody can plug in 0, but what about 1? Anybody know what cosine of 1 radian is? I didn't think so, so that's why this would be bad. You know what would be better? Pi over 2 pi, 3 pi over 2, 2 pi. And I will make this chart for you. You just gotta fill it in. Okay, so if I plug in 0 into the original equations, what do x and y come out to? 1 and 0. So that means the particle starts here. This is your initial position. That's where you start. Okay, now how do you figure out how the particle travels on the curve? Well, plug in these values of t. Okay, I'm just gonna call on people here. Pi over 2, Wayne, Gina. Plug it into the original, and you got cosine pi over 2? Wait.
0.
Wait.
0.
There you go. And then plug in pi over 2 here.
Sorry, I
Whoop.
can't really. Is it sine?
Sine t.
Oh, okay. 1.
Yeah. Okay. Oh, the particle goes here. So here is the particle at pi over 2. That's about 1.57 seconds later. Okay, now pi. Pi Wang. No. Cosine pi. Yeah, there you go. -1, and then there you go. Oh, so the particle goes here now. Oh, what am I doing? Okay, now 3 pi over 2. Who's got 3 pi over 2? Tanaka.
0.
And
-1.
woohoo! So the particle goes here now. And then when you plug in 2 pi, come on, 2 pi is the same thing as 0. I'm not going to call on anybody for that. The particle goes back there. Oh, so the particle is traveling counterclockwise around the circle like this. And what will happen if you keep on going? Because look, it says greater than or equal to 0. It's just going to keep going like this. Okay, people in physics, what is this? This is going to be on your AP exam in physics. Really? It doesn't matter what level of physics you're taking, come on.
Centripetal?
Okay, and what is yeah, but what's the overriding topic?
Circular motion?
Uniform circular motion. Okay, you know what? I guarantee you this is probably on the AP physics exam. So the particle is traveling this 1/4 of a circle every pi over 2 seconds. True or false? The velocity is constant.
False.
That is false. You probably had that on your physics quiz. Why? Because the velocity vector here is like that, but then over here, right? Because didn't they tell you the velocity is tangent to the circle? And then over here, this is the velocity, but over there it's like that. Is that constant? Is this arrow pointing in the same direction as that arrow? No. True or false? The speed is constant.
True.
Yes, the length of the vector is the same throughout. Okay? But the direction is different, so that's why velocity and speed are two different things. And then what did you guys learn about doing. So this is what the acceleration vector looks like. Don't worry, fourth quarter, this is gonna come up again when we do calculus. See, the thing is, when you're taking baby physics like you guys are taking, then you gotta memorize all these different things. But once you know calculus, you just have to memorize the little things, and then you can use calculus to get the others. All right, but we're not here to learn physics. We're here to learn the math. So what you have to do is you gotta come up with this equation. So I'm thinking on this test, usually there's only 8 problems. There's gonna be 8 points each. You'll get 36 free points. 4 points for this, 4 points for this. That's how it works. But you gotta be aware now. Sometimes you have a circle. The particle doesn't just keep going around like this, you know. Sometimes it does this. In fact, it's gonna come up with the right come up here. That shocked me. In fact, there's gonna be one problem that goes like this. There's one problem where it goes like this, and it starts slowing down, and it's getting closer and closer to some point, but it just never gets there. So you just know, and then there's some problems where you have a circle, but the particle does this. It does crazy things. So it all just depends on what kind of equation you got. Okay, let's kick it up another notch. I don't know why, but this is harder. One of the hardest things for students to understand, because you got to know trigonometry. That's why. X equals secant t, y equals tangent t, and let's say t is greater than or equal to 0. Okay, so the first thing you got to do is come up with the rectangular equation that the particle is traveling on. So how would I eliminate the parameter here? Should I solve for t in one equation and plug it into the other? Yeah, you can. Except like if you solve for here, you have t equals secant inverse x. Nothing wrong with that, and then plug it in this one. You just have to draw the triangle. I think you guys can do it. Or a better way, use trig identities. Do we have any identity that has secant and tangent in it? Yes, the other Pythagorean identity. And do those identities involve secant and tangent, or secant squared and tangent squared? Secant squared and tangent squared. So you need to square these equations. So square the first equation, square the second equation. Now you have to decide. If I want to get rid of this, do I add the equations, subtract, multiply, or divide? It's going to be one of those 4. Yeah, you subtract. Okay, so x squared minus y squared equals, is it 1 or negative 1? You guys got to make sure now, because that's 4 points right there. Well, what's the identity? Okay, look, if you just completely forget everything, look. Cosine squared theta plus sine squared theta equal 1. Everybody remembers that one, right? How did we derive the one with the secant and tangent? Divide both sides by cosine squared. Divide this by cosine squared. Divide this by cosine squared. Divide this one by cosine squared. So therefore, what is secant squared minus tangent squared? It's 1. It's not negative 1. Negative 1 would be a fatal error for that part. So this is the graph that the particle is traveling on. Hey, I know this. It's a, and don't say circle, because that's a plus sign, it's a circle. But this is a minus sign. Hyperbola. Okay, so how do you graph this hyperbola? Like this is over 1, this is, remember, this is a squared and this is b squared. We still gotta remember that. Well, you just have to remember how to graph it. I'm not gonna ask you to find a full sign and things like that, right? You just gotta be able to graph it. So, a squared is 1, b squared is 1. That means a is 1 and b is 1. So from the center, you go 1 to the right and 1 to the left, 1 to the up, 1 to the down, and what do? We make and right because the x comes first. The graph looks like this. This is not the hard part. We didn't get to the hard part yet. Okay, now, how does the particle travel on this hyperbola? We make a chart. And I will give the chart to you. Oh, we're just restricted, so we're just going to make it tiny then. Pi over 2. Oh, you know what? Let's go pi over 4, pi over 2, 3 pi over 4, pi. Darn it. We're going to have to continue the chart on this side then. Okay, what comes after pi? 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. Okay, you just start filling in the chart. Okay, so here are your original equations. You always plug it into the original equation. If I plug in 0 here and here, what do you get? Chan? 0 and 0, plug it in. You got the easy one.
I forget how to do it.
My arms are getting tired.
0.
Okay. Most people do the x first. What is cosine of 0?
1.
Flip it over.
1.
There you go, 1. Oh, so the particle starts here now. If you come up with a point that's not on this graph, you did something wrong. The point has to be on the graph. Okay, so here is the initial position now. Where does the particle go? Well, let's plug in pi over 4. Again, plug in pi over 4, which is root 2. Trying to make me think, huh? And then 1. Okay, so pi over 4 seconds later, the particle is at the point root 2 comma 1, right there. Okay, now what about at pi over 2? What's going to happen there? Calabrese Kenny. Pi over 2, pi over 2. Huh? Okay, secant is 1 over cosine. What is cosine pi over 2?
0.
Okay, and 1 over 0? Undefined. What about tangent pi over 2? Sine over cosine. 1 over 0. They're both undefined. What does that even mean? Undefined basically means it's infinitely large. That's what it is. So what the particle is doing from 0 to pi over 2, it's doing this. So the particle starts here, it goes from here to here in pi over 4 seconds, and then in the next pi over 4 seconds, it goes like this. It just goes infinitely far away. That's the easy part. Now, what happens when you actually hit pi over 2? It's going to be infinitely far away, and then what's going to happen is the particle disappears. It goes into hyperspace. But then now you have to figure out where it's going to reappear. So how do you figure out where it's going to reappear? Well, what's just to the other side of pi over 2? You know what might help you? Draw graphs. Do I really need to? Well, if you need help. Okay, doesn't tangent go like this? And secant hump up? See how the x and y coordinates, they're going to infinity? They're both getting infinitely large. But what about on the other side of pi over 2? Doesn't the tangent graph, okay, here's pi over here. Doesn't the tangent graph go like this? And then the secant graph is, right, humping down like that? So just on the other side of pi over 2, secant and tangent are both really large negative numbers. So what would happen, where are you on this graph if x and y are really large negative numbers? What quadrant are you in? In the third quadrant. We are like way down there. So what happens is when you hit pi over, anytime these equations become undefined, the particle is just going to explode infinitely far outward, and then it's going to disappear, and then you got to figure out where it's gonna reappear. In this case, it's reappearing way down there, and then it's coming up here like this. And then if you wanna fill in the numbers, you can. Why don't we do that then? Plug in 3 pi over 4. Who's got 3 pi over 4? Liu. Plug in 3 pi over 4. Okay. Close. Farther. Negative root 2, because cosine is negative in the second quadrant, right? And then tangent 3 pi over 4. Close. Negative 1. Am I going to be there with you taking the test? No, you're close. No, these are trig values. You're telling me the hardest part of this problem is figuring out trig values? Oh boy. So at 3 pi over 4, the particle is here. So t equals 3 pi. What about pi? Okay, who's got the easy one? Pi. Graham, you got the easy one. Pi. Maybe not so easy. Maybe we gotta bust out the Know Your Angles app. Because pretty much almost all the problems involve trigonometry now. No. Okay, what is cosine of pi?
1.
Close. Negative 1. Flip it over. Okay, negative 1. And tangent pi? Sine over cosine.
0.
Okay, 0. So negative, also the particle goes here. So just from 0 to pi, this is what the particle is doing. It goes like this. Disappear, reappear infinitely far down there. Okay, now after this, what's going to happen? Well, you know what? Just to save time, I'm going to fill in the chart for you. If you plug in 5 pi over 4, you're going to get negative root 2, and then this one's going to be 1. So now you're going to be here. Okay, t equal pi, t equal 5 pi over 4. And then what happens when you plug 3 pi over 2? Undefined, undefined. So what's going to happen is it's going to explode infinitely far out. Right at 3 pi over 2, it's going to disappear. Where is it going to reappear? So you need to know what's going to happen after 3 pi over 2. So let's continue our graph. So here's 3 pi over 2. So tangent looks like this, and then secant is like that. So the x-coordinate secant is going to be what? A really huge negative number. I mean, what am I doing? This is the secant graph. It's going to be a really large positive number, but tangent's going to be a really large negative number. Where is that? If x is really large positive and y is really large negative. In the fourth quadrant. So it's going to go, and then it's going to reappear down there. Then it's going to come back here. So, if you were to keep on going, this is what the particle does. And it just keeps doing that. Okay, you know what? Why don't we graph it on our calculator, because you guys are supposed to check it. See, check on your graphing calculator. So how do you graph parametric equations on your calculator? Well, you find the parametric app. It's like if you want to graph polar, go to the polar app. Parametric app. Okay, make sure you're in radian mode. Hey, how come mine doesn't tell me? Doesn't the upper right hand corner tell you if you're in radians or degrees?
Yes.
How come mine doesn't tell me? Okay, I'm assuming I'm in radian mode already. Okay, apps. Where's parametric? Oh, there it is. Oh, look, I have it right there. I got secant and tangent. Mr. Park, where's the secant button? Actually, I think you guys actually do have a secant button. I'm not sure where it is, but I just typed in 1 over cosine. Now, I just want to show you the default setting. So if you go go to plot setup. Okay, look at the t range. T goes from 0 to 6.28. What do you think that 6.28 is? That's 2 pi, right? Pi is 3.14, so twice that is 6.28. So the default setting is, it's just going to go 0 to 2 pi. Okay, and it's going to plot a point every 0.05 radians. And then that's your standard screen there, and then press plot. Boom! See, it does it so fast, all you can do is see the graph. If we could somehow slow it down, let's see, let's try this, just for funsies. Plot setup. Change this t-step to something really small instead of 0.05. How about 0.001? Let's just try that. See what happens. Plot. No, it's still too fast. Your calculator is too efficient. So your calculator will show you what the graph looks like, but you gotta do the important part. You gotta figure out how the particle is traveling. So you just gotta, and of course, you know, I'm not gonna, on the test, I'm not gonna just tell you t is greater than 0. I'm gonna just restrict it so like t is between 0 and pi. I don't wanna make it the whole graph, you know why? Because the people that don't know anything, they're gonna just draw the whole graph. Right, so if you only went from 0 to pi, let's do it in a different color, the particle did this then. And then, oh, I missed. Right there. That's it. It's only this upper right branch and the lower left branch. So that's what happens when one or both of these become undefined. It explodes out to infinity, and then right when you hit that point, it disappears, and then you gotta figure out where it reappears. Which means you gotta know function behavior. That's why we study all these things. All right, and then now, I wanna show you some, oh, it's blocking. Oh, got it. There's gotta be a way of controlling it so I don't have to keep walking back here. Put my desk in the front. Okay, look at number H. I'm not gonna tell you how to do, I'm gonna start you on it. You guys are going to finish it. Look at letter H. I'm going to leave that on the board because we're going to do something with that after. Okay, I'm erasing this one. Okay, here is H. X equals 2 over 1 plus t squared. Y equals, or should you want me to do the whole thing? You're supposed to say no. T is greater than or equal to 0. All right, now how do I eliminate the parameter? Well, I don't see any trig functions here, so we're not going to use trig identity. So should I solve for t in one equation and plug it in the other? And you can. It's going to work. But you're going to have to do a lot of algebra. Like, you know what? Which equation is easier to solve for t? This one is really hard because you got a t squared and a t there. You're going to have to use quadratic formula if you do it for this one. This one is easier, but it's still good. Look, if you solve for t in this equation, what are you going to get? 1 plus t squared is equal to 2 over x. T squared is equal to 2 over x minus 1. T equals plus or minus the square root of 2 over x minus 1. Take that and plug it into this equation. Can you see it's going to be a mess? Okay, so Mr. Park, there's got to be like a better technique than that, and yes, there is. But this only happens in certain cases. I will tell you right now, this problem is on the test, okay? Do you notice that these two equations look very similar? Except one equation is simply t times the other one. Would you agree that this equation is simply t times this one? So whenever you see that situation, you write that down. The y equation is equal to t times the x equation. Yes or no? If I multiply the x equation by t, you get the y equation. Okay, so whenever you see this situation, this is what you do, and then what do you think you're going to do now? Solve for t. T equals simpler than what we first did. Which one looks easier to plug into? The first one, because it doesn't have the T there. But it doesn't matter, it's gonna come out, whichever one you plug it into. So take this, plug it in for T, now you're set. Do you want me to go one more step? Okay, then yeah, you're right, you guys need to practice your algebra. And if I remember correctly, this one turns out to be a circle. But this is the one where I was telling you, it goes like this. And then it starts slowing down. I'm not really sure which direction either. It starts slowing down and it gets closer and closer to a point, but it just never gets there. Anyway, you can watch the video for that one because you gotta understand why it's getting close. You know what? Maybe I should talk about this problem. No, you guys are gonna do that. Watch the video if you need. Okay, so this is about as hard as it gets right here. But then now, next time we're gonna start going into 3 dimensions. So, what if I gave you these same equations, except now, I added a 3rd dimension. Z equal T. So, can you imagine what the particle is doing? You've got a particle moving in space now. So, in the XY plane, remember this problem? It's just going around like this. Uniform circular motion. But what happens if you add a Z coordinate now? What would be the path traced out by the particle? So that means the Z coordinate, see, if the Z coordinate is always 0, then it just stays in the XY plane. But then the Z coordinate keeps getting bigger. So it goes like this. See, Z is getting bigger. It's going like this. What is the path traced out by that? What is this shape that comes up in science all the time?
Spring.
Yeah, but we have a name for that.
Helix.
Okay, the what?
A helix.
Helix, there we go. We were gonna play hangman. You guys learned about helixes, right? DNA, double helix. This is just single helix. So if somebody were to tell you what is the path traced out by the particle, it's a helix. Like those of you going to engineering and physics, helix comes up all the time. And there's so many famous graphs defined parametrically too. We'll talk about that one next time. We're not going to do it today. So these are the basics now. These are just basic problems. So I'm going to tell you, you need to know your trig identities, like right here. You need to know your double angle for cosine. Yeah, well, Mr. Park had 3. Well, pick the right one, right? Since this is sine, you're going to pick the one that has the sine in it, right? And which one is that? 1 minus 2 sine squared t. And then over here, Mr. Park, I see sine 3t. Do we have to know triple angle identity? Well, you guys never memorized it, right? Did any of you memorize the triple angle? Then you're going to have to derive it then. So let me get you started on that one. How do you derive the triple angle identity? Is that x or y? That's y. Doesn't really matter. So if you don't have it memorized, then what do? You gotta go 2t plus t and then expand. We gotta know all the identities, Mr. Park. Well, look on tonight's homework on the vector. Did you guys do the vector homework? Vector 5? Didn't you have to know double angle? Yeah, I'll just tell you right now. I made the test. Oh, a lot of the problems came from vector 5. You're gonna have to know identities of, otherwise you can't do the problem. Anyway, here I'll just get you started. What is sine of gorilla plus banana? Sine of the first, cosine of the second, plus or minus? Plus cosine of the first, sine of the second, and then I think you guys know what to do from there. Now you gotta know double angle identity. Something's wrong there. Oh, the first is 2t this way. I knew something didn't look right. Now it's right. All right, so you can see this chapter it's very short, but it has everything in it. You gotta know, you gotta be good at algebra, you gotta be able to plug this vertical and horizontal asymptotes yet. Don't worry, it'll be there. So yes, this is BC calculus right here. Except in BC calculus, you know what we do? See, these just give you the positions. What we do in calculus, we figure out velocities and accelerations. In fact, here, physics, did you guys do projectile motion? Kinematics? Okay, here, look. This is, and of course, for those of you who didn't take physics yet, hopefully you can remember this and you can dominate. Normally we would spend, maybe we should this year, maybe we have extra time. We can spend one night on projectile motion. You know what? I'm gonna think about that. Because usually we're short on time. But this year we might have extra time. These are your projectile motion equations. This gives you the x coordinate and the y coordinate. This is the position. Do these equations look familiar? Yeah? So here, let me just tell you. What would happen if you plug in 0 for t? 0, 0. So the particle starts at 0, 0. Now, what the heck is this, Mr. Park? V naught cosine alpha, V naught sine alpha. What is that? That's your initial velocities. So, here's your velocity vector. So when you launch a projectile, right? That's your initial velocity vector. How do you componentize this vector? If this is alpha right here. If this is V or V naught, initial velocity, then how do you componentize this vector? Wouldn't this be V naught cosine alpha, V naught sine alpha? That's what these are, right? And then you know that gravity doesn't affect left and right motion, it only affects the up and down motion. That's why you got this GT squared, right? Anyway, and then you also have to memorize a whole bunch of other equations too. The thing is, once we learn calculus, in the 4th quarter we're going to learn, then all you have to do to compute the velocity is just do something with these equations. To compute acceleration, you just do something with those equations, and so you only have to memorize these. That's why calculus is so good. That's why Sir Isaac Newton invented it, to study his study of physics. All right, we're done. So you really gotta learn these things now. You can't just, I hope you guys aren't just copying off the written solutions that I gave you. Because this, I'm telling you, I remember one year